Hello students. For example number 2, we'll look at a slightly more involved type of question. Specifically, you're being told that you have a circular settlement tank or sedimentation tank. You're given the diameter for this tank, which is 100 feet. You're also told that the flow rate, the average flow rate through this tank is 200 megaliters per day. Finally, you're informed that the detention time through this tank is 2.25 hours, 2 1/4 hours. You're then asked to calculate what the height of the water is in this tank. That is the height of the water. Another way of calling this height of water is by an acronym that you've been informed about in a previous slide, in a previous video previous to this, which is the side water depth, SWD. Okay, let's get to it. I've also listed on the side here some useful formulas that will help us solve this question. The first one, detention time, right? You're familiar with this one, which is equal to the ratio of the volume of water in a tank divided by the flow rate of water through that tank. I also included for you the formula for the volume of a cylinder, which is equal to the area of the base, the circular area, times the height of that cylinder. Okay? And then here I've included the area of a circle, which is either pi r squared or pi d squared divided by 4. Okay, let's get to it. What we're trying to find out is what the height of the water is in this tank. Okay, let's get to it. So the first thing we want to do is make sure that we have everything we need. So by looking at this formula, I have the detention time, I have the flow rate through it. By using this formula and solving for the volume, I can calculate the volume of water in this tank. Then, after I calculate the volume of water, by rearranging this formula, I can calculate the height of water. So I rearrange this formula in terms of the volume of water. You will notice that based on what I get here, hours and days don't cancel out, right? They're both units of time, but they don't cancel out. So we have to do something about that. In addition to, the volume is typically, for metric units, expressed in cubic meters rather than liters. We could, if we wanted to, leave it in liters. I'm choosing to make things a little more difficult and converting everything to cubic meters. So do you remember how to convert megaliters or liters to cubic meters and how to convert days to hours? Just a reminder, I know that thanks to the use of your very useful mobile technology, you can find out these conversion units. Here they are in case you can't remember them by heart. So you can check to see whether or not you're able to obtain these same conversion units. A quick note, I am calling hours with the symbol HR, although hours usually has a symbol of only H. And that's because I don't want you to be confused by the H that I'm using for the height of water. Okay, this height here of water. All right, assuming that I can convert everything properly, the answer that I get for the volume of water is 18,750 cubic meters. And again, this is the volume of water in that settling tank. Okay, I have the volume of water. I can calculate the area of this 100-foot diameter settling tank, and I then calculate the height of water. I'm sure you figured out that by now the answer is yes, so let's do it. I'm going to now use this formula. I'm going to rearrange it in terms of the height of water, because that's what we're looking for. So firstly, I rearrange the formula. So the height is equal to the volume of water divided by the surface area. because it's a cylinder. The formula would be slightly different if it were a different shape. I also remind myself that the area, in this case, is that of a circle. Okay? And my final step, voila. And again, a quick note. This D here is for diameter. This D here is for day. So be careful about that, okay? Okay, so I have the formula figured out. I can now actually go about calculating what the value is for this. Now, if you'll allow me, I'm going to move up here because it's getting a little cramped at the bottom. So the height of water is equal to voila. Do you notice something odd about this formulation? That's right. We have feet at the denominator and we have cubic meters at the numerator. Meters and feet don't cancel out easily. One is metric, the other one is imperial. So either we convert feet to meters or we convert meters to feet. I'm going to pick that I'm going to convert from meters, from feet to meters. Okay? Because I know it by heart, I know what conversion to use, which is 1 foot is 0.3048 meters. But I'm sure that you can use your mobile technology to find out the same thing, right? So if I convert this properly from feet to meters, I get 25.7 meters. I've calculated what I was looking for, that is, what is the height of water in a tank. I'm left with only providing a concluding statement. Voila. The height of water in this tank is 25.7 meters. Now let me point out to you a couple of occasions where you're apt to possibly make a mistake. First, by forgetting to square both the unit and the number, right? Sometimes you might just be drawn, because you're in a rush, to put a square only in front of the unit or after the unit and forget to square the number for the diameter. The next one is this. Forgetting to realize that the height of the water is different from the height of the tank. The tank is actually taller than the amount of water. And that's because the tank is equal to the height of water plus the freeboard. You remember what the freeboard is? And if you don't worry, it's in your lecture notes and the lecture videos.